ஆமா. அப்ப நான் சொன்னேன், பிள்ளைகள வச்சு எடுத்துட்டு வந்தா. ம்.
அவ்வளவுதான்.
Great achievement of Chera. We cordially thank.
இந்த கரும்புள்ளி செம்புள்ளி
Paramanathan sir, good evening sir, we welcome you. We could not able to hear your voice sir.
Hello, anyone? Can you hear me?
Yes sir.
Okay, thank you.
Yes.
So, can you see the screen? Screen is visible?
Yes, sir.
Okay, thank you all of you. Good evening to all of you. I welcome you all for this session. So, my title of my session is Feature Extraction from Image.
Sir, we'll start with the formal invitation sir.
Okay.
Yes sir.
So, for that only I asked.
Okay sir, okay.
Good evening, everyone. Thank you for joining us today. We are excited to have you at today's 5-day International Virtual FDP on image feature extraction using MATLAB, organized by Department of PG Mathematics of PSDR Krishnamal College for Women.
Let us collectively seek the blessings of the Almighty. May His grace guide our endeavors and illuminate our paths as we delve into the realms of knowledge and understanding.
Together, we gather not only to celebrate the elegance of numbers, but also to explore the profound impact of mathematics on various fields and unveiling the intricate of tapestry of its applications in our modern world.
To all our participants, I encourage you to actively engage in the sessions, ask questions, and seize the opportunity to network with your peers. Your presence here today is a testament to your dedication to continuous learning and professional growth. And I have no doubt that you will derive immense value from this session.
तीनों ही बोलना चाहिए था ना कि हमें ऐसे इंस्ट्रक्शंस नहीं थे.
Participants, we kindly request you all to mute your audio. Now, I would like to call Dr. M. Nila, Assistant Professor, Department of PG Mathematics, PSDR Krishnamal College for Women, to introduce our intellectual guest speaker today, Dr. R. Paramanathan, and also address the gathering.
Thank you, Da. Wishing you a happy evening. Respected faculty members, esteemed guests, Dr. Paramanathan, I am delighted to extend a warm welcome to all of you on behalf of the Department of Mathematics, PSDR Krishnamal College for Women, Coimbatore. It is indeed a privilege to have you all here today as we gather for the 5th day of a 5-day International Virtual FDP on mathematics and its application. I would like to extend a heartfelt welcome to our respected principal, Dean, head of the department, who supported us in conducting this FDP. I welcome all the faculty members and each and everyone for this International Faculty Development Program. This 5-day FDP paves way to enrich knowledge in various fields of applications of mathematics. At this illustrious moment, I would like to join with this gathering to happily welcome our esteemed chief guest, Dr. Paramanathan, Assistant Professor, Department of Mathematics, Amrita Vishwa Vidyapeetham, Coimbatore. Welcome you, sir. Dr. Paramanathan has a sound academic qualification which includes PG, BEd, and PhD from Gandhigram Rural University. His research interest is mathematical modeling using fractional functions and machine learning. With his academic excellence, he has more than 15 years of teaching experience with a teaching interest, which includes the subjects like operation research, machine learning, random process, and complex analysis. As a part of research, he has more than 20 publications in various journals like Applied Mathematics and Computation, Communications in Computer and Information Science, Numerical Optimization in Engineering Sciences, and also an active research supervisor for many students of MSc Mathematics and Applied Statistics program. Sir has received doctoral research fellowship from Jawaharlal Nehru Memorial Fund 2009, New Delhi, and GRU Research Fellowship for Meritorious Student by Gandhigram Rural University, Gandhigram. He has delivered more than 15 invited talks in various educational institutions on the topic mathematical modeling, recent challenges in fractals, and computation using MATLAB. With this short notes, it gives me immense pleasure in once again welcoming you, each one of the gathering for today's session on the topic image feature extraction using MATLAB. I once again extend a warm welcome to all the participants who have joined from various institutions all over the country. I hope this FDP will provide a platform for sharing and discussing about the various topics. Welcome you all.
Thank you for the introduction, ma'am.
Without further ado, we warmly welcome Dr. P. Paramanathan sir, whose expertise and insights are sure to enlighten us on the topic image feature extraction using MATLAB. The session is yours, sir.
Thank you, madam. Thank you for the opportunity. Good evening, participants, every one of you joined here. So let me share the screen. So aim of my talk is introducing MATLAB. So I cannot assume every one of you familiar with MATLAB. So I can give some small introduction about MATLAB. And then slightly we can move to the feature extraction techniques using MATLAB. So my intention is not introducing the built-in functions already existing in MATLAB. So directly you can substitute the image and you can extract the features. Not like that. I will instruct you a simple way to extract features from images. So before that, let me give the introduction to MATLAB. So whoever installed the software in the MATLAB, so parallelly you can work with me. So you can get experience, and that will be easy for while handling images. Hope my voice is audible.
Yes, sir. Voice is audible, sir.
Can you get the? Hope all of you seeing the second slide. So if any disturbance, just inform me. So matrix laboratory. So short form is MATLAB. MATLAB. So it is a good scientific programming environment, and it is a good tool for manipulation of matrices. So because we are going to feed all the inputs in terms of matrices, that's why we are calling this as MATLAB. And it is having great visualization capabilities. So it consists of plenty of built-in functions, and it is very easy to learn, and it is simple to use. So this is my slight outline about the introduction. So slowly I will show you the MATLAB screen and variables, array, matrix indexing, and what are some operators and display facilities, the flow control, and how to use the M file, and how to write the user-defined functions, and then conclusion. So hope all of you seeing the screen, MATLAB. So this is a MATLAB window. Here on the right hand side, you can see the workspace, and the left hand side, you can see the current folder and what are the files available. And this position is where you are having two arrows, that is command window. And here you can write the code that is handling M files. Okay. So this is the MATLAB screen, you can see. So this is a high level language. You can have so many conveniences while using MATLAB. In all the fields of research, you can go for image processing, signal processing, solving differential equations. So this is the dominated language nowadays. See the flow. So purpose, how the flow going on. So MATLAB will be completely handled by directly the command line or mat files or M files. M files consists of functions. So that is having input and output capability. So it is convenient, better you can use M files instead of type the command in command line. Because in the command line, you can type some 2 or 3 commands, and then M files, you can type plenty of commands. One click, it will run and it will give you the output. And these are some operators we are going to use in MATLAB. That plus symbol, minus symbol, star, and slash, and cap, and conjugate transpose symbol. That single quote. So these symbols will helpful for addition, subtraction, multiplication, division, and cap power. And the transpose, we can use the single quote. So when you're writing the mathematical expressions, you should be very careful when you are using these symbols. And the relational and the logical operators, we can use, that is double equal, that is for equal to, and the second one is for not equal, and less than strictly smaller, and greater than strictly greater, and less than or equal to, and greater than or equal to, we can use these symbols. And the AND operator, the vertical line, that is OR operator. So what I shown in the first slide, so that is view of command window. So here you can type the commands in the command window. You look at the arrow, and here you can see the current directory, because there is a that mapping is required. Your file and the current folder, that should be mapped. You have to keep the file in the current folder. Otherwise, we have to change the directory. And whatever the variables you are using in your program, that will be stored in workspace. And whatever the commands you are using in your MATLAB program, that will be stored in command history. So in the command line, in the command window, if you press the up arrow and down arrow in your keyboard of your computer, so that will give you the commands, whatever we used, up arrow and down arrow. So no need to type the command again and again. Simply you press the up arrow and down arrow, you can get the commands, whatever we used. So defining the variables, it is convenient in MATLAB. So no need to specify integer, double, float like that. Directly you can use values. Automatically that will take the nature of the variable, assigns to numbers, and you can use any kind of variable like x equal to 5, x1 equal to 2. So that convenience is there. And everything will be in double precision except the matrices. So 1 cross 1 matrix is the double precision, single value. So array and matrix. So first, I think it is visible. The vector. I'm typing some numbers, 4 numbers, 1, 2, 5, 1. So that can be a 4 component vector. So we can use the command x equal to square bracket 1, 2, 5, 1. So the vector will be generated. Then if you click X in the workspace, it will show these four numbers 1, 2, 5, 1. And this is generally there is 1 cross 4. Okay, so having 4 columns and 1 row. And this can be represented as a matrix when you have to type z equals 1 2 3 semicolon 5 1 4 semicolon 3 2 minus 1. So each row is separated by semicolon. So 1 2 3 that will be printed, and then the 5 1 4 will move to the next. So semicolon is like enter. It will take the next 3 numbers to the next row, and 3 2 minus 1 to the next row. So transpose you can find for this matrix y equal to x dash, single quotes. I already explained to you. So x is a row vector 1 2 5 1. If you use transpose, you will get column vector 1 2 5 1. And long array and matrix. Suppose I want to generate a number 1 to 10 continuously. Then no need to type all the numbers. Better you can use t equal to 1 to 1 east symbol, that is colon 10. So then that will generate the numbers between 1 to 10. So by default, it will take the distance is 1. Suppose I want to generate the vector with some increment. I want to, with the desired increment, then in between the colon, you can give the increment. So it will generate the numbers based on that increment. So that is a convenient. And the last one, b equal to 1 colon 4 semicolon 5 colon 8. So that will give a 2 cross 4 matrix arrangement. It will take the numbers 1 to 4 and 5 to 8. By default, the distance between the numbers is 1. So generating vectors from functions. There are these are all built-in functions. Suppose you want to generate a vector with fully 0, then no need to type 0 0 0. Simply you can use zeros of 1 comma 3. So that is 1 row 3 columns 0 0 0. And you can similarly another built-in function 1 ones of m comma n, where m is row and 3 n is column. So ones of 3 comma 1. So it will generate all the ones based on the dimension given. And another function is rand. So the rand function is it will generate random numbers based on uniform distribution, rand of 1 comma 3. And the main thing in MATLAB is we can convert anything in terms of a matrix, but how to access the matrix? So that is important. So you consider this matrix 353682273, that is stored in the matrix A. So I want to get A of 6. So here I'm using A of 6. So A of 6, 3 5 3 6 8 2 2 7 3. Okay, so it will trace column wise. So 3 6 2 5 8 7. So the seventh element. Next, I'm adding the dimension, not a single form. A of 3 comma 2. So the third row, second element, that is also 7. So in this way, there are two ways to extract the element 7 from the matrix. So you can use dimension method, directly you can indicate the number. And the next one, A of 2 comma colon. So second row, because notation is m comma n, m represents rows and n represent column. So A of 2 comma colon. So 2 fixed second row, but given colon means entire column. So it will take the elements 6 8 2. That means column elements you will get is 6 8 2. So that is A of 2 comma colon. And another one, A of 1 to 2 comma 2. So here we preferred the rows 1 to 2, first row and second row, but we want only the second column. So then we will get 5 and 8. So in this way we can use, or we can access the matrix. That is very important. We should understand the concepts related to accessing the matrix, accessing the elements of the matrix. Later, if you are giving the input as image, so the image also stored as matrix in the MATLAB. We are giving that input. So there we must know the commands to access the matrix entries. So if you are giving some outside range outliers a of -2 and a of 0, you will get error. And a of 4 comma 2 also not possible in this matrix. And concatenation, that is also the important one. So here I have 1, 2, 3 vectors, x equal to 1, 2, y equal to 4 comma 5, and z equal to 0, 0. So here I'm using in the square bracket, simply I'm typing x space y. Then it will concatenate, it will merge the two vectors x and y. So I will get 1, 2, 4, 5. So concatenation in another form, b equal to x semicolon y. So as you know, that semicolon will separate the rows. So the first row 1, 2, the 4, 5 will come automatically the next line. So that is the way you can use. And while concatenating, the dimension should be matched. Otherwise, you cannot get the answer. You will get error. And flow control, we can have so many loops in MATLAB, if, for, while, break. Whatever our convenient, we can use the convenient loops. And matrix operations, that is also essential in image processing. We have A and B, two matrices, and here these four operations are possible: A plus B, A minus B, and Z equal to A star B and transpose. So A plus B, A minus B, A star B, that represents product, and transpose A dash, single quotes. So that will give you the matrix operations. And these are the general terms for extracting the matrix elements. Already we discussed A colon comma N, A M comma colon, because in the first one N is fixed, and second one M is fixed, and third one row is fixed, and we are choosing M to N. So like that we can have the general terms. Here you have to substitute the values of M and N based on your dimension of the matrix. So calling functions, so maximum element, minimum, and union. So this kind of built-in functions we can use as calling functions. And dot star. Suppose I want to multiply two vectors element by element, then we can use dot operator. So dot star means element by element multiplication. Dot slash, element by element division. Dot cap, element by element power. That is squaring the entire vector, but element by element. So it will take first element and square it, second element, it will square it, like that. So the use of dot, that is explained in the slide. Element wise operation, you take the matrix A, and you know x equal to A of 1 comma colon. So that will take the first row with all column elements 1, 2, 3. And y is A of 3 comma colon. That is 3, 2, minus 1. Then I'm doing b equal to x dot star y. Then you see the element wise 1 into 3, 2 into 2, and 3 into minus 1. Similarly for division and similarly for square. So without dot, if you give x square, you will get error, because this is suitable for element by element multiplication and division and square. And these are some basic functions in MATLAB. Disk clear, it will clear the screen, clear the variables in the workspace, and CLC, clear the screen, close all, exponential of x, absolute value, square root, log 10, REM, sine, cos, tan, a tan 2. So this kind of basic functions we have in MATLAB. This is a control structure in if loop. When you are making the conditional statements, that you are seeing the right hand side. If A is less than B, there we have to give the condition. Then that will print some MATLAB commands. Else if B not equal to 5, some MATLAB commands, end. So that is a position for typing the conditions. We can give two conditions with the AND operator, A greater than 3 and B equal to 5. So that also we can use. These are some control structures for I equal to 1 to 100. So that will print some MATLAB comments. And the next one I'm giving, that is for I equal to 1 to 100, I didn't give any increment. So obviously that will take 1. For second one, for j equal to 1 to 3 to 100. So there it will take the increment 3. So like that it will go. For this is a structure of for loop. And for and if everything should end with end command. That is important. So this is while. So the right hand side you can see some example while with and operator. I'm giving the two conditions, a greater than 3 and b equal to 5. Then the loop will execute, and that also should end with end command. So the next one, use of m file. So if you the file will be automatically saved with the extension .m. So go to file, open. So open MATLAB and go to file, or here you can see new. Click new. You can click script. Okay, that will open one file here. So that is the new M file that you are seeing. And if you click save, it will go for saving prompt. There you have to give the name for the file and ensure that the directory where you are using and where you saved the file, that must be same. Otherwise, it will ask, shall I change the directory? Then you have to give yes, then the program will be executed. So that way you can create M files. So after creating the M files like this, you can type all your commands for your programs. If you want to find the area of the triangle, area of the circle, like that, if you want, you can define all your programs. And if you put a semicolon at the end of the line, you cannot see any output in command window. So that will block the output at the end of the line if you put semicolon. And MATLAB functions. And suppose if you are not interested in using built-in functions, or for your research problem, some functions are not available in MATLAB, then you can create your own function. So how to create the function? If built-in function is not available, and this is a structure, function variable equal to function name of n. So whatever it is. So this is a structure. Function variable, that is output, variable is output, is equal to function name and input, that n part is input. This is the structure we have to follow to create function, defining the function. I will explain you with the example later. And one more thing here you have to observe, this function name and what the iterate. Here you are seeing the iterate. The iterate is a function name as well as the file name. The file name should be saved both. So that is indicated through arrow, you see. Function name is iterate and file name is also iterate. So in that way, you have to save the file. So once you created the function file like this, every time if you want to use that file, no need to open the file. Simply type the function and give the input, that will give you the output. You see, here iterate of 5 is given. N equal to 5. So based on the for loop, it will multiply the two numbers. If it is 1, you will get 1. If it is 2, you will get 2 into 2, 4. 3, 9. So like that, it will work. So here I didn't open the file. Simply I'm using the input 5. N equal to 5. Iterate 5. So you can define multiple outputs also like this. Function equal function p comma q equal to sort 2 of a comma b. Here that sort2 is a function name that you can see the file name is also sort2, that we have to ensure, otherwise your function will not be executed. So another example with the multiple inputs. So here a and ind, without these two inputs your function will not be squarer, that function will not be executed. This is a way to write the user defined functions. And once you completed the function in M file, close the M file, then come for command window. Otherwise, if you want to use, if you want to call that function, you can call in M file other as well as the command window. Simply open command window and type the function name and give the input. It will work. You have to verify whether the function name is correct or not. Otherwise, it will not be executed. And the use of whos command, whos, it will give you the history of the variable used in the current program. whos. And for simple plots you can use these commands x and a, plot for multiple values, simple command. And for generating the polynomials you can use these commands. So each and every entry refers the order of the polynomial. Here you can see x cube plus 2x square minus 4x plus 3 is referred like that. 1, 2, minus 4, 1, 2, minus 4, 3. So the poly2 sim will give you x cube plus 2x square minus 4x plus 3. And we can use these commands also, roots, poly, and solving the equations you can use these commands. You can type the equation. You see for example x square plus 5x plus 6. Then you can use solve of in single quotes x square plus 5x plus 6. In another way, in single quotes, solve of x square plus 5x plus 6 equal to 0. That also you can use. And in the function roots, that a must be the vector that refers the order of the polynomial. And symbolic representation. So this is very important in MATLAB. So using simfun for generating a as symbol and generating t as symbol, we have to use these commands. A equal to sim of single quotes a, or simply you can type sims a. Nowadays they are referring like that, sims x of t or sims a, like that you can define. So entire program that will be treated as symbol in all your solutions, that will be treated as symbols you can get. You see sims f x y, all f x y, all the three are symbols. So I can use f equal to sim fun of x plus y comma xy. That will give you the answer f of x comma y equal to x plus y. That is the meaning. If you give the input for x and y, it will give you the output 3 because function is x plus y. The variables are x and y. So here f is a sim function because we defined sims f x y. And similarly for the next sim function x square plus 5x plus 6, that is sim function in x. So once you run the command, f of x will be generated. Then you can type f of 1, you will get the corresponding answer 12. And you can find the derivative for this function also, that is using diff of f. Diff of f. So x square plus 5x plus 6. If you use diff of f, you will get 2x plus 5, the derivative of the function. So now I think this introduction is enough for understanding the MATLAB. Then this will go fully mathematics. Let me go. So my ultimate aim is giving the introduction about MATLAB. Now we will move to how to extract the feature from the image. So for that we must have the knowledge of handling the MATLAB commands, because MATLAB is the best tool for handling images. So we must know the commands for handling the images. And then hope all of you seeing the screen image feature extraction using MATLAB. So I will explain you the steps for extracting the feature from images, because we have to get some useful information from images for handling that. It may be texture images, it may be other kind of images, whatever it is, we can get some useful information from the image as features. So how to extract the features without using any packages available in MATLAB? Simply you can write the code and you can understand. The basic built-in functions you must know are, screen is visible? Any one of you please reply, because I'm sharing the second.
Yes, sir, the screen is visible.
Thank you. Thank you. So these are the MATLAB functions you must know for getting this. If your purpose is you are going to use only one image and you are going to get the feature, then some of the built-in functions are not required. But you are going to generate features for some 100 images, 150 images, then these functions are very much needed. You see the first function, that is sprintf, second one num to string, third one imread, and fourth one strcat, that is string concatenation, and the next one cell string, cellstr. So some participants, if you want, you can note down this: cell string, repmat, and reshape, and rand perm, randperm, is member, find, block proc, and num to cell, cell to table, and write to table. So usually in if you want to do some machine learning problem, we need features in the form of test data set and a training data set. Usually we will split in 80-20 ratio. So if image data set is given to you, the image data set consists of some 112 images. You take some standard texture images like Brodats texture images that consists of 112 texture images, the whole data set. So we have to find the feature for each image, and then we have to split the data set into 80-20 ratio for test and training. So for that, the best technique is splitting the image, because suppose your image is 512 cross 512, split the image into small pieces, small sub images. Then for all the images you have to divide like that. Then 112 for all the 112 images you have to do the split up, generating sub images. Now for all the sub images you extract the features. Okay, after that you split 80-20 from all the from each image. You have to separate 80-20 ratio for test and training, and finally you go for validation. Okay, so validation part I think you can follow, but I will give you the idea about how to extract the features. So hope all of you noted the built-in functions available in MATLAB. These are enough. So first one, let me give a small idea about what are the features, what are the informations you can extract from images. So one is local binary pattern, that is very standard one, local binary pattern. And second one, fractal dimension. So the basic method, differential box counting method, and as usual wavelet coefficients. So these three are the if you refer any research paper without these three features, you cannot find any image processing papers. Okay, so these three are essential, I believe. So other than this, plenty of features are available, but I will give you the idea with that. So how to get the local binary pattern? You see, you have to take the image. This is algorithmic structure. If you see the image, you can understand quickly. Look at in the image, you take some 3x3 pixel from left top corner. Okay, so I took 3x3. And in that center one is 88. Center pixel is 88. Now we have to compare the 88 with all the remaining pixels. So compare 88 and 124. Which one is greater? 124 is greater. Then put 0. If the pixel is greater than the center pixel, put 0. Otherwise, put 1. So you see 0 and 65 is less than 88, 1 and 0, 1, 1, 0, 1, 0. So now arrange everything in the order given in the diagram 0, 1, 0, 1, 1, 0, 1, 0. Now convert this into decimal form, you will get 90. So similarly, in the image, you see the image will be treated as it's a matrix form. You can understand. You see, suppose I want to generate one image x equal to im read of. So we can use this d1 dot gif. Okay, now I took image d1. So what is the image? So can you see these are the images d1, and if you want to see x, you see these values are, every value is a pixel value. Every value is the pixel value. Grayscale image started from 0 to 255. And if you want to show the image, you can use the command im show of x. Can you see the image, all of you? Participants, any one of you reply me? Can you see the image in the window? The texture image?
Yes, sir.
Yes, sir.
Thank you. Yes, yes. So this image is in GIF form. Okay. Now I loaded the image in MATLAB and I'm seeing the output, but the image is stored as a matrix. What you are seeing in the screen, stored as a matrix. You see, these are the pixel values. So in that, some we have to work the local binary pattern for all the 3x3 images. So totally I may get totally you see. So this is totally 9 pixels, okay, except the center we can have 8. So in the image, every 9 pixel we have to consider, and we have to generate the identify the corresponding pattern. So for this we are getting 90. For other we will get some other pattern. So like that, we have to extract this local binary pattern. And another way, that is fractal dimension. We can compute the fractal dimension. So here also we have to consider, we have to take some 2x2 box, 2x2 matrix from the image that is loaded in MATLAB. You can take some 2x2. From that we have to identify the greater pixel and lower pixel. So using the formula d equal to log n by log x, where n is number of boxes and s is box size, we can identify the fractal dimension, but this is a single number. For one image, you will get one value. But in the feature LPP, local binary pattern, we will get vector of values, because for each 3x3, we are getting one number. Okay. So now the usage of sprintf. So what is the use of sprintf? Already I told you, if your aim is finding the features for only one image, this sprintf is not required. Directly we can use the command. Already I typed the command in the MATLAB that you can use, and you can find the features. Suppose you want to execute plenty of images, having 500 images, 1000 images in the folder. So every time you cannot run the program and store, you cannot store the values. That is a very difficult work. So for that, you have to create the loop. The program will take one file from your folder and then it will execute and then it will find the feature for that image. And finally, you will get the Excel sheet. You will get all your values, feature values are stored in Excel sheet. And that is 80-20 form. Local binary pattern for test and local binary pattern values for training, 80-20 ratio. So that is a beautiful thing. So how to achieve that? So using sprintf, here I took as z equal to 1. Participants, you can note down this command. Sprintf of, we can use percentage s, and percentage s refers character, okay, and percentage d refers decimal value, okay. So in the single quotes, I took percentage s, percentage d, percentage s, comma, percentage s first. So it will take the path of the folder d original products d. So that is path of the folder. And here I took z equal to 1. And another one I gave in single quotes dot gif. So only this sprintf accepts value for z. Remaining everything will be treated as constant. It will print the value. So if you run this command, what you will get output is I equal to, in single quotes, d is of d colon the path, that is a path d1 dot gif. Okay. So after that, it will go for, you have to use the command imread. So every time if you change the z value or if you are giving the loop for z value, suppose you are having 100 images in your folder data set, then z can be iterated for 1 to 100. So it will go for z equal to 1, you will get d1. The image set is d1. Image name is d1. And z equal to 2, d2. So it will take one by one from your folder and it will go for analysis. So this sprintf is very much needed. And if you want to know more about sprintf, you can refer this website. And the next imread. So once I created the, say in single quotes d colon original products, that is a complete address I have given. Then I can use imread and I can type normally that because that is stored in I. That is stored in I. Hope all of you understand this. This full thing is stored in I. So directly you can use image equal to imread of I. So if you type im show of image, it will show the image. So this is convenient for generating the for loop. Next, num to string and cell string concatenation. I will show the purpose why we are using this. Participants, can you see the Excel file? Any one of you?
Excel file is not visible, sir.
Excel file?
Sir, the PowerPoint is not.
Okay, now?
Yes, sir. It is visible, sir.
Yes. Now you see, in the last, this is the training file. Using LBP, I generated the training file. In that last column is name of the image. So for classification, this is needed. D1, you see, D1, D1, D1. That image is splitted into so many sub images, and in that I took only the 80 part. So the last column feature values and the last column must be name of the image. This is useful for giving the target value. Okay, so I think all of you understand the purpose. We have to print that name of the image at the last column. So for that, we have to use this num to string, cell string, and the string concatenation. So here also I took for example z equal to 1, and I am converting this number to string. Number will be converted as string. So z equal to 1. Now then 1 will be converted as string. Then in image name, cell string I'm using. Now I'm doing the concatenation. String concatenation of, because in all the images D is common. Only thing is the next number only change. D1, D2, D3, D4. So the num2 string of is at 1. So if you use string concatenation of these two, you will get the output like this. And cell string is in each cell of the Excel next value, this will be printed based on your number of images. So the outcome of the first three line is D1, that is in cell form. You can see the brace. Okay, so that is a purpose we are using num2 string, cell string, and string concatenation. Next, reshape. For reshape command is very essential, because we are finding the values in different form, and finally we have to create or convert the values in the form of vector. So for that we have to use reshape value. Suppose for example we are taking x equal to 1 to 10. Already I explained 1 to 10 will generate the numbers 1 to 10 with the distance 1. So all the numbers, and I'm using the reshape command of x comma 5 comma 2. So 5 comma 2 in the square bracket. So it will create 5 rows and 2 columns. This will convert 1 comma 10, that vector, into 5 comma 2, that is 5 cross 2 matrix. That is how it is reshaped. We can see in the right hand side. 1, 2, 3, 4, 5, one column. 6, 7, 8, 9, 10, another column. So this is a way you can reshape your outputs. In image feature extraction, that reshape command is very much essential. We have to convert all the feature values into vector form. You see in the Excel file I have shown now, everything is in vector form. So for that, this reshape command is used. And again, if you reshape y, you see in y we have 5 cross 2, 5 row 2 column matrix. Again I'm reshaping that y comma, I used in square bracket 1 space 10. So again you can get the original matrix, that the original vector 1 to 10. And another important function is rand permutation, random permutation of integers. So this will help to identify the 80-20 percentage split up. Okay, you can, but here the problem is you cannot get the unique 80-20 at any time. If you run one time, you will get randomly 80-20 data set. If you run second time, you will get another version. Okay, so that is the beauty of this command, random permutation of integers. So for example, you take x equal to 1 to 10. So if you get the output 1, 2, 3, 4, 5, all the numbers, then if you find size of x comma 2, you will get 1 comma 10. Then size of x comma 2 value is, that is a dimension of x, 1 row 10 column. So you will get 1 comma 10. That the second value is 10. So size of x comma 2 equal to 10. In index, I'm finding index, that is variable name. So rand perm of size of x comma 2 comma seal of size of x comma 2 star 0.20. Okay. So the seal command, that will convert the value to next greater integer. So size of x comma 2 equal to 10 star, that is multiplication with 0.20, and that is permuted with size of x comma 2. So it will choose two values. That is 10 star 0.20 means two values. It will choose two values, that is 1 and 8 from this one. So now index we got 1 and 8, remaining 80%. Remaining 8 values. Participants, I think all of you following this. Total is 10 value. I need to split this into 80%, 20%. For that, randomly I took, because I don't have any purpose. It can be random. So I used a random permutation with 0.20. It gave the index 1 and 8. Remaining except 1 and 8, remaining numbers will be converted in the 8 form. You see? For that, we can use the member function isMember and find. That will give you another 8. You see, I'm taking m equal to 1 to size of x comma 2. If you run this command, you will get 1, 2, 3, 4, 5, 6 up to 10. So here the use of isMember is only it will take the members of that 1 and the 8. So m1 equal to isMember of m comma int x. If you run this command, you will get this vector 1. Only 1 and the 8th place you will get 1. Remaining all are 0. Only first and because we got the index 1 and the 8. 1 and 8. So only in the index places we will get 1, other elements are 0. Now apply find the command where you are getting 0 at 8 places. So you will get the remaining 2, 3, 4, 5, 6, 7, 9, 10 except 1 and 8. Now the data 1 and 8 belongs to 20% and 2, 3, 4, 5, 6, 7, 9, 10 belongs to 80%. So once you got these numbers, the corresponding data you can extract. Already we discussed from the matrix how to extract the values. Next one is now we understood how to split the data into 80-20 form. Now how to find the features, because we have to process block by block and the block size is 3, 3. So here this is a built-in function useful for distinct block processing for image. That is block proc, BLOC, PROC. The syntax is block proc of A, that is your matrix, and m comma n, the block size, and what function, what you have to compute from that. So here we understood. Here the function is LBP because we need to find local binary pattern. And mn we understood 3 comma 3 because we are going to analyze for we are going to find a local binary pattern for all the 3 class 3 values in the matrix. And the another one is the matrix value. So that is stored in V2. So block proc equal to, I'm stored in DV. Block proc equal to V2 comma 3 comma 3 comma function 1. Okay, what is function 1? That is LBP. So local binary pattern should be computed for all the 3 cross 3 matrices available in the matrix V2. So I took T equal to 1 to 64. If your image size is 512 cross 512, I am splitting that into 64 blocks. Then every block will contain 64 pixels, 64 pixels, 64 cross 64. So it will, for executing the loop, first value of t is 1. It will go for blocks B1, first value B1. Then it will take the image and it will do block processing. And finally, you see the last step. Without a reshape, you cannot escape. You have to reshape the values and it will be converted as vector because that is given in square bracket. So once you run this command and finally, let me show the program. You see all these things given. Whatever I explained, I used this. You see, yes, printf used. And next im read, num2 string, cell string. So I got the blocks and finally reshaped. And I used rand perm for 80-20 conversion. And isMember, find, and finally block proc. Then finally reshape. I got the vectors. I got the feature for all the sub images. Now the very important work is I need everything in the form of Excel sheet because that is a CSV form, CSV file, comma separated value file, because that is easy for analyzing, doing classification with different classifiers. So for that we can use this command. You see, everything is converted in the form of cell. Okay, I'm using num to cell and then cell to table, and finally using the command write table, write table, and I'm giving the name for test and training, LBP test and LBP training. So if you run this command, here I gave only 5 images. I took for 5 images. So if you run this command, you see, so D1 taken, D2, D3, D4, D5. So all these images taken and features will be generated, and that is splitted into something will be disturbed. Oh, sorry, the Excel file is open. Okay. D1, D2, D3, D4, D5. Yes, now all the 5 images taken and the features are generated, that is splitted into 80-20. From each image 80-20, that is important. From image D1 80-20, from image D2 80-20. Finally, all the 80s are grouped in LBP train and all the 20s are grouped in LBP test. So now I will show the Excel file for test. You can see. You see in the folder, the 2 files are generated. I gave the name LBP test.csv, LBP train.csv. So left hand side you see LBP train, LBP test. If you open the file LBP test, you see, you can see that 20%. Okay, see the Excel file. Participants, can you see? So this is the Excel file for test. Okay, this is the Excel file for test. At the end, I told you now we have to type the values D1 D1 and then D2 D2. This is a test set. All the 20% values are stored here. So beyond that, suppose I'm not interested in doing these kind of programs and I want to use directly in the built-in function available in MATLAB, then you can use this command, extract, participants seeing the screen, extract LBP features with the cell size 32, and normalization none. So with that, you can extract LBP features directly from MATLAB. But the thing is, you will get only the uniform LBP. There are so many varieties in local binary pattern available. If you are using MATLAB with this function, you will get only the uniform LBP, no other features. So if you want to write your own LBP program and your own 80-20 split program, then you must use these, you must know these functions, built-in functions available in MATLAB. Okay. And finally, your test set and training set will be ready in the MATLAB folder, and that you can take it to classification problems based on the classifiers you are interested. Thank you, participants. Thank you. Any questions?
Participants, if you have any queries, you can unmute yourself or post it in the chat box.
Good evening, sir.
Yes, sir. Yes, sir.
Sir, your presentation is very nice, sir. Can you
Yes, sir.
suggest MATLAB book for the preparation, sir?
Sir, now I am not remembering any specific book.
Okay, sir. Okay, sir. You may send
Yes, sir. Yes.
send through the organizing committee, sir.
Sure, sir. Sure, sir. I will share this code. Everything I will share, sir. You can
Okay,
follow
sir.
that.
Thank you so much,
Yes.
sir. Wonderful presentation.
Thank you, sir. Thank you.
Thank you very much, sir.
Yes, sir.
Welcome, sir.
Any other questions? Yes, sir.
Good evening, sir.
Yes, sir. Yes, sir. I'm hearing you.
Yes, sir. Nice presentation, sir. Actually, lot of information we got. Sir, if possible, can you share this PPT, sir?
Sure, sir. Sure, sir. I will share to the organizing committee. Madam Neeraja, madam,
Okay,
will
sir.
get an answer.
Yes, sir. Ma'am, organizing committee, ma'am,
Because
please kindly share this PPT to in that WhatsApp group.
Because I know, sir. Because quickly you cannot type and you cannot see the output. That I
Yes, sir.
understood.
Yes, sir. That is the problem.
But only I conveyed the
Sure.
information. But with that code, you can execute, and if any doubt, you can contact me through email.
Okay, sir. Sure, sir. We will contact. Thank you, sir.
Thank you.
Thank you for the nice information.
Thanks.
Participants, if you have any other queries, you can unmute your mic and ask, or else you can post it in the chat box.
Good evening, sir.
Yes, sir.
Good evening, sir. Sir, I want to ask one thing. I am
Please.
using meta-heuristic techniques, and I am using MATLAB codes for that.
Okay,
but
sir.
I am not very comfortable with those MATLAB codes. So, which book or something can I follow to learn that level of MATLAB?
Sir, actually, if you are if you have interest on coding, then that will be
Yes,
convenient, sir.
Fine,
You can
sir.
refer completely the MATLAB website for all the, because the problem is we don't know the much built-in functions available in MATLAB, sir.
Fine, sir.
And always we will try to get a code for our problem directly. That is the issue. If suppose if you are having interest in writing the code and try to get some built-in functions and connect it and use this code also, sir. This way of writing the code you can follow.
Okay.
And you can achieve a result, sir.
Fine, sir.
And
Fine,
I
sir.
can suggest you some book, but I'm not remembering now. I will send the book names to the organizing committee. They will circulate you.
Okay, I request the organizing committee to please post that book name in the group, WhatsApp group. Thank you, sir.
Sure,
Thank you, sir.
Sure.
Thank you,
Thank
ma'am.
you, sir. Thank you. So any other questions, sir?
I hope the questions are over, sir.
Okay.
Thank you so much, sir. We sincerely thank you for dedicating your time to us, and your insights were not
Thank you,
only
madam. Thank you all.
enlightening. Thank you, sir.
Thank you all of you.
Your insights were not only enlightening but also motivating. Your valuable perspectives on image feature extraction using MATLAB garnered high praise from all the attendees. Your significant contribution played a crucial role in the success of the event. We express our heartfelt gratitude for generously sharing your knowledge with us, sir. Thank you so much, sir.
Thank you, madam. Thank you all of you. Thank you.
Before we move to the vote of thanks, participants kindly switch on your videos for a group photo. Thank you, participants. Now, I call upon Dr. A. Neeraja, Assistant Professor, Department of PG Mathematics, to present the vote of thanks.
Thank you, Dara. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to the Almighty God for making today's occasion a resounding success. As Malcolm rightly said, education is our passport to the future, for tomorrow belongs to the people who prepare for it today. Today, I take this opportunity to express my deepest sense of gratitude and appreciation to all those made this fifth day of your 5-day International Virtual FDP on mathematics and its application. On the topic, image feature extraction using MATLAB, such a success. To begin, on behalf of Department of Mathematics PG, I would like to thank our resource person, Dr. P. Paramanathan sir, who spared time from his busy schedule to grace this occasion. The whole session is fully engaged with the basic concept on MATLAB and practical knowledge of MATLAB, flowchart, MATLAB functions. Also, we gained a knowledge of image processing and also how to extract image features, split the image into small images with a ratio. Thank you very much, sir. Thank you, sir. Next, I would like to thank our beloved Secretary, Madam, Dr. N. Yasoda Devi, for her generous support for this event. Your encouragement has constantly bolstered all our endeavors. Thank you, ma'am, for your constant support. Next, I would like to thank our principal, ma'am, Dr. P. Meena. Your guidance will always help us, ma'am. Thank you, ma'am. My heartfelt thanks to Dean, Mathematical Science, Dr. L. Lakshmanan sir, for his guidance and encouragement in all our efforts. Thank you, sir. I would like to thank the torch bearer of this event, our beloved HOD Madam, Mrs. K. Sharmila, for reading and inspiring us in working towards the goal of conducting this 5-day International Virtual FDP. Thank you, ma'am. I express my special thanks to our team members for their cooperation in making this function a fine success. I would like to express my appreciation to all our resource persons that day one, Dr. A. Prema Kripakaran, Associate Professor and Head, Department of Information Technology and Information System, School of Computing, Nile University, Nigeria. And day two, Dr. R. Prakash, Associate Professor, Department of Mathematics, RV College of Engineering, Bangalore. And day three, Dr. Gi Chun La, Adjunct Professor, VIT, Malaysia. And day four, Dr. S. Hariharan, Assistant Professor in Mathematics, Dwaragadas Vaishnava College, Chennai. And day 5, Dr. P. Paramanathan, Assistant Professor, Amartya Vishwa Vidyapeetham, Coimbatore. I would like to thank Professor Gi Chun La who have taken time out of his busy schedule to attend all the 5 days and grace this occasion with his presence. Your presence has added an extra spark to this event and made even more special, sir. Thank you, sir. I would like to thank people who worked behind the scene to make this event happen. From the bottom of the heart, I would like to thank our technical arrangement team members, Mr. Rogit and Mr. Ranjit. Thank you, both of you. I would like to thank our budding girls who made this event joyful with their impressive performance. Your days of hard work were evident in your acts. Thank you, Haripriya, and thank you, Dara. Thank you, girls. Last but not the least, I would like to thank everyone who actively participate all over the world. Thank you, participant. Thank you, one and all. Thank you.
Thank you, Mom. Participants, the feedback link have been posted in the chat box. Kindly fill the form.
Yes, ma'am. Check in YouTube also, ma'am.
Okay, ma'am.
Participants, you'll receive your certificates within 10 to 15 days. And before you leave the meeting, kindly fill the feedback form. It is posted in the chat box. Participants kindly fill the feedback form which is posted in the chat box.